So next up, we've got team 3, LLIMA, the large language imaging assistant. So Lindsay, you're online and presenting, and some of the members of the team are coming up on stage. LLIMA, oh my goodness. Thanks so much. That's great. Lindsay, are you there?
Yes, I'm here.
Perfect, we can hear you.
Okay, great. I believe Adam is going to be presenting.
Okay, great. You're online and
yes.
Okay.
And screen sharing and all that stuff. Okay.
Thanks.
Hi, everybody. My name is Lindsay Marrero. I'm coming to you from Ohio. So hello, Austin. And we are Team Cleveland Clinic. We are going to be presenting to you our hackathon project called LLIMA, as in lima bean, Large Language Imaging Assistant. We basically wanted to create a AI-driven, if you will, Clippy, but better. So for radiologists. Next slide, Adam, please. So the problems that we wanted to solve today are basically twofold. Problem number one, we want to create a easy to read, plain language interpretation of a diagnostic report for a patient. So this is kind of an ongoing problem. I'm sure you're all aware of the struggles that we have with this. And some have resorted to manual solutions, and they're very accurate but time consuming. So we kind of wanted to experiment it. We kind of wanted to experiment using LLMs, large language models, and see what the pros and cons of doing something like that are. So our solution is actually using an LLM called LLAMA. And problem number two, we wanted to provide the radiologist with some similar images to the one that they're currently interpreting and some metadata around that. So our solution for that is a reverse vector image search. So step one for problem number one, we wanted to, again, create a patient readable report summary. We take a input of the patient ID and we do a fire call against or with a C# web API and get all of the diagnostic reports for that patient. And then we send those diagnostic reports to the LLAMA large language model meta AI, and we request a patient readable summary. We use prompt injection for this. So basically we say, hey, we are a radiologist, but we want to summarize the report. And it is self-hosted. No additional training was done in this case, but we wanted to see out of the box what LLAMA could do for us. And the output is, again, a patient readable summary of a clinical report. We did use the Gradio web interface for both of these solutions. Next slide, Adam, please. Okay, and then for problem number two, again, we wanted to do a reverse image search. So we've got a patient image, and we used a ResNet model to perform a vector search. We created a database with all of the vectors in the melanoma data set. We kind of wanted to do something a little different and use the SIIM ISIC melanoma data set for this, which consists of about 33,000 images. And then the output is going to be the top 15 images that are similar to the ones that we're looking at, or to the one that we're looking at, and an assessment and charts that summarize the metadata around those images. So we'll flip over to demonstration.
Thank you very much. So now we're going to do a live demonstration of LLIMA. So I'm just going to switch over to Chrome. So here you can see the Gradio user interface. So we have two tabs at the top here. This tab, report summary, is going to be our step one that we talked about. And then this tab, reverse image search, is going to be our step two. So essentially how the assistant works is you're just going to go ahead and select your patient from the dropdown. So right now we have one patient populated from the SIIM database, SIIM and that loads the original diagnostic reports on the left. So you can see we have 3 here for Andy, and we can essentially just click run, and on the right hand side of the screen it will give us the summarizations for those 3 reports. So you can see it has a 1 summarizes the first report, then 2 summarizes the second, and then for the third one you can actually see this is a drawback of this. So with these large language models, something that kind of goes wrong sometimes is they'll get a bit creative, they'll get suggestive. So it's pointing out that you may need further evaluation. Is that the case? Would need to be verified by a radiologist. So then we go ahead to our step 2, the reverse image search. So you go ahead and you select your image. So we have this image of Andy here that we're going to go ahead and select. And then we can just click search. So it's forming our vector search now. On the left, we have all of our matching images. So we have a gallery containing those. And then on the right, we have a table containing all of that metadata that Lindsay mentioned, as well as a few plots to provide us with some insights on that data. So yeah, that is LLIMA, our large language imaging assistant. I'll kick it over back to Lindsay now to finish up the presentation.
Thanks, Adam. So yeah, lessons learned. So we had generally good summarization results using an LLM, but then, they weren't so good. They, like Adam said, they got a little creative. It added some nonsensical additions. I think it said recommend follow-up of CT of lungs and MRI of brain, which I don't know, how accurate that is. And then another drawback is the hosting needs. It does require a little bit of computing power. So, that might be something to consider if you were to do something like this and productionize it. Next slide, Adam. Okay, yeah, what's next? So obviously this is just a prototype. We would need to do some additional testing of the LLM results to ensure accuracy. Obviously, we don't want to give patients any bad information that could be detrimental to their care. So, and then we'd want to also do some specialized models for image retrieval, better fine tuning for clinical applications. Again, we didn't do any sort of training here, so it was all out of the box type stuff. We did create that vector database for the image retrieval, which took about an hour, which wasn't so horrible, but we'd like to do some more specialized models. And then it would be nice, right now it's a very manual process, again, a prototype. We'd like to develop further integrations with existing radiology applications and automation. So, maybe the radiologist could have a plugin that says, hey, I want to approve this translation or decline it or edit it or whatnot. And with that, we'll take any questions.
Great. Thank you so much, Team 3.
Thank you.
Okay, questions from the judges.
Nice presentation. Thank you. Kind of a two-part question. One is how specific was this to the LLIMA being, or can you easily convert it to a different large language model if there is one that is curated for healthcare, or if you want to switch from Meta to Google? Is that a big thing, or is that really core to this project? And the second thing is, if the goal is to make it patient readable, have you put some thought into how do you know when you've succeeded? How do you validate? How do you measure that? Or just kind of generally, if you put some thought into it. Thank you.
Sure. Yeah. So I'll take the second question first. I mean, obviously, patients have different, knowledge, clinical knowledge, and not everybody is baseline. So that's a really good question. I personally haven't looked into it that much, but anything's better than a clinical report, right? I mean, I think we all can say we've been there. Maybe not the actual radiologist, but Googling each phrase to see what that means. So I think any kind of summary is better than none. But the more simplistic you can get in those results, the better. As far as LLIMA goes, I can't see why not, but we would need to investigate that further. I mean, LLIMA was very, it was very achievable for the hackathon presentation. It was very readily available, but I can't speak to the other ones.
Great. Okay, thank you again, Team 3.
What about just quick last question? Is there any use of like structured approach? I see that there's the input of those diagnostic reports is a bit structured in HTML, but is there any formatting in between, like any sort of formatting, medical formatting that you use?
Like any standardized
Structured data models, yes.
right.
Fire, whatever.
No, everything is all verbatim at this point. But that might be another you know, something to look into. Maybe that would improve the results a little bit.
Lindsay, if I may.
Yes.
We did use the Fire to bring over the patient information, and our goal was to bring the images, but we ran out of time in the hackathon. And currently we were using JPEGs and not DICOM. Our goal is to improve it to use the DICOM images.
Fantastic. Thank you so much.
Thank you.